everybody. So we're going to start our lecture 8 here, starting chapter 5. This is a survey of the solar system. So this is going to get us started for our more in-depth delving into the solar system, which is going to come in the next chapters after chapter 5. So chapter 5 is kind of a broad overview, and we'll be studying a lot of different things in chapter 5 and be going into depth in subsequent chapters. All right, well, let's get started. Here's a question for you. Let's imagine that you have a large grapefruit. This kind of looks like an orange here, right? But it's a grapefruit. So imagine a grapefruit, nice chunky grapefruit. And imagine that that is the sun. So we're going to reduce the size of the solar system by a factor of 10 billion. That's what you would have to do to reduce the sun to the size of a large grapefruit, about 14 centimeters in diameter. How big would the Earth be on this scale? Okay, so let's see. An atom, a ballpoint. So in other words, we took a little ballpoint pen and put a little dot on the grapefruit, a marble, or a golf ball. So this is a little bit of a tough question, and I think if you haven't thought about this before, my guess is you're going to get it wrong. When I teach this class, usually I ask students this question, and a lot of people think marble. Well, in fact, it's a ballpoint. An atom would be way, way, way too small. But it's a ballpoint, and that's pretty darn small. So let's take a look. Why is there another one? Who knows? Okay. Here you go. Here's a little picture of the Earth next to a big solar prominence, which is a big flare of solar material sort of coming up and back down. And you can see how small the Earth is compared to even that, right? You could fit a bunch of Earths in that, in between the two, sort of the bridge made by this prominence. So Earth is quite small compared to the Sun. I think one of the issues that people face in really understanding the scale, how big the Sun is that we all build models of the solar system when we're in grade school, right? And we never, ever make the sun the correct size. Well, for one thing, it would be really hard to carry the thing around, right? So let's take a look at a picture of that. Let me see if I can get this going. Here we go. All right, and we'll do that in a second. Let's talk about the solar system at this scale, right? So now we are still on that scale of 1 to 10 billion scale, right? So we've scaled everything down by a factor of 10 billion. And there is a model of the solar system at this scale that's not that far away from us, right up in Washington, D.C. on the National Mall. I hope that all of you have been up there to see museums. But there is this walking, planetary model where you have the sun, then the Earth is about 15 meters away, Mars is 23 meters away, and hopefully some of you have walked this. And then the whole solar system at the 1 to 10 billionth scale is here along Jefferson Avenue, next to the Air and Space Museum and the Hirshhorn Museum. So it's really fun to go out there and actually walk that and think about the fact that it's a 1 to 10 billion scale. Okay, so let's see. What about, let me go to the next slide here. All right, what about the next closest star to us if we think about this 1 to 10 billion scale? All right, so on the 1 to 10 billion scale, remember, it's just about a quarter mile to Neptune, right? On that 1 to 10 billion scale, if you go back to the slide, right, this is about a quarter mile from the sun out to Neptune. Nice walkable distance. And Neptune is really about 4 or so light hours. So we said a little bit about light years before. Light hours just means the distance that light travels in an hour. So it takes light about 4 hours to travel from Neptune to the sun, or from the sun to Neptune, right? Light from the sun. How far would you have to walk on that 1 to 10 billion scale to get the next closest star, which is 4 light years away, right? Well, let's see. Think about this. Think about what you think. I hope that you're guessing right now that you have a sort of a scale in your head about how this 1 to 10 billion works. And in fact, the next closest star, you'd have to walk across the United States. All right, so it's quite a far distance away. The distance between us and the next star is enormous. 4 light years may not sound like much, but it is a huge distance. All right, well, what about the Milky Way? Well, the Milky Way is 100,000 light years across. On that same 1 to 10 billion scale, how big will Milky Way be? Well, quite big. About 1.2 times the distance to Mars, so 50 million miles. So if you were going to continue on your trek from the Mall in Washington, from the Sun out to Neptune, about a quarter mile, keep walking to get to the next star, which is Alpha Centauri, you'd have to walk all the way past Mars to get to the end of the Milky Way, basically. Okay, so here's the scale of the little scale model I was talking to you about. So you can see that we have, quite a challenge to make one of these models and take it into your classroom, right? So let's take a look at a video that gives you a little better sense of how all this works and what these scales are really like. Come on, video. Here we go. Of course, the planets in order of planet and our moon, in order of size here. Giant Jupiter. And then the truly enormous Sun. But there are bigger stars. Yep, pretty big. Okay, so that's kind of an amazing thing, just to notice that our sun is enormous, right, compared to all the planets, but it is certainly not the biggest star. Okay, so what does the solar system look like? Well, really, when I put this slide here, it just means we're going to be studying sort of the major properties of the solar system and some of the major properties of the planets. Again, we're not going to delve into each planet in this course. Okay, so I like this picture because it really shows you all the axial tilts. So if you look, right, we know Jupiter doesn't have much of an axial tilt. And then there's Earth sort of leaned over, Mars. Mercury doesn't have much of a tilt. Venus doesn't have much of a tilt. Saturn has a tilt. And look at Uranus. It's just tilted all the way over. So really interesting. So we'll see some of that as we go through our little survey here. Okay. So there are 8 major planets that all have nearly circular orbits, right? We saw that Mercury has something that's a little bit more elliptical than the others, but mostly it's nearly circular. Pluto and Eris are smaller than the major planets, and they have more elliptical orbits. We saw that too. And really, Pluto is demoted from a planet. We'll talk about why that's the case. All planets are going in the same direction, basically orbiting in the same direction around the sun. Most large moons also orbit their planets in the same direction, which is also the direction of the sun's rotation. So everything's sort of going in the same direction and mostly in the same plane as we saw. Okay, so pause the video and answer the question.